with another problem. Today's particular problem is deleting the alternate linked list. So we have to make a linked list such that the alternate link values are being deleted. So you can see that we are given a single linked list. We have to delete all the alternate nodes of the list, then delete all the nodes present in the even position. Delete all the nodes in the list and delete all the nodes present in the even position. Even means by skipping one element, right? So if I consider this is as 1, then 2, 4, 6, then these are all even positions. Okay, these are all even positions. Okay, so even positions mean from if I start with 0, then I have to skip one element to reach 2. So if I start with 2, I have to skip one element and reach 4, and if I start with 4, I have to skip one element and reach 6. Okay, so that's how I can just say that I am deleting the even positions. Okay, so what comes first in your mind? That okay, we have to use the concept of pointer. We have to use the concept of pointer. So concept of pointer helps you decide how you can skip the list and the nodes efficiently. So if you see a given input value 1, 2, 3, 4, and 5, the ones which are at even positions and the ones which are alternate in nature. So if I start with 0, this is at my even position. Okay, this is as my second position. 4 is also a even position. So these two values should be deleted. These two values should be deleted. If I delete, what I am left with is 1, 3, and 5. That's all. That's all about today's particular problem statement. So what is the algorithm? What we can see clearly. The algorithm is saying that we are having a base case to check if the list is empty or has only one node. That's very simple. Every algorithm has a base case. Now we have to current pointer. We will have to initialize, say, node head. Okay, node head. So current equals to head, I can say, which will direct me to the head of the linked list. We have to loop along such that the node does not become null, means there are no more elements left, and we have to delete the alternate values by just going at 2x, means skipping alternate values. And lastly, we have to move the current to the next. So if I'm at 1, what I can see, I'm moving at 3, so my current value becomes 3. At 3, I'm moving at 5. That means I'm using a next operation to skip from this value to this value, from here to skip and reach this value. Okay, what is the time complexity I can achieve? The time complexity, what I can see, is big O of n, and the space complexity is big O of 1. Okay, so without any waste of time, let's go and check the solution. So if you guys see that I am taking a list 1, 2, 3, 4, 5, and 6, the answer should be 1, 3, and 5. Okay, the answer should be 1, 3, and 5. Okay, just a second. Yeah, 1, 3, and 5. What about my list of size of 8? Okay, so I can write 7 and 8. So if I just execute this, what will be my answer? Uh, Sorry, just a second. Yeah, 1, 3, 5, and 7. Why? Because 6 is being deleted. So if I start from here, the alternate values will be 1 and 3. 2 is removed. From 3 to 5, 4 is removed. From 5 to 7, 6 is removed. And from 7 to 9, 8 is removed. Okay, that's how. So we have to check the head is null, or the element which is a head dot next is null. Then we will just return. Or what we can do, we can point our current node as head. We will iterate until the current dot next does not becomes helping us to skip the element basically. And what we can do else is that we can point it to the next pointer. Okay, so we'll just simply follow the steps what I have told over here. We'll simply follow the steps what I have told over here. So initially this is I'm having a head. Okay, so I will have a condition if head, okay, dot next equals to null, or head equals to null, then I can, what I can return, I just can simply return. Okay, that's what I'm doing. That's what I'm doing. Yes, after that I can take a new node, say new node equals to head. Okay, and I can iterate a loop while new node dot next not equals to null, or new node not equals to null. I guess that is what I have to do. Let me just check. New node dot next not equals to null, or new node not equals to null. Okay, so what I can do, I can move my new node dot next equals to, we have to move 2 pointers ahead, right? We have to move 2 pointers ahead. So what I can write, new node dot next, okay, and I can write new node equals to new node dot next. Okay, let me just check. Yeah, new node equals to new node dot next, and the while loop is completed. This is the, let me just compile and check whether it works. The driver code is already being made. So I don't have to wait. Okay, so null pointer exception. If head dot next, if uh, node new node at 36, while new node dot next, mm, while new node dot next not equals to null. Okay, okay. So I've just made little sorry. I've just made a silly mistake over here. Okay, another mistake. What is the mistake? Delete alt at 36. So new node not equals to null. New node not equals to null is satisfied. New node dot next not equals to null. New node dot next not equals to null is also satisfied. New node dot next equals to new node dot next. I have to. There is some silly mistake I am supposed to make. Head dot next equals to null, or head equals to null. Then I'm just giving a return. What is it? So is the class new node, they are not taking it? So let's compile now. Okay, so I don't have to do this. It's already there. There is some null pointer exception. I don't need. I'll just simply check what is the mistake I have made. So node current equals to head. So what is it? I can't take a new node. I have to write current or what? This is funny. Node, new node. This is my while. So let me just make it current. So current after take. Let's compile. No, it's something else. The error must be something else. I have to check. I'm taking a node head. Okay. Current node current equals to head. Am I doing so? Am I doing so? Node current equals to head. Yeah. What is the problem then? This is the void delete next at line 29. While current dot next not equals to null, null pointer exception is coming, right? While current dot next not equals to, okay, I'll just check. I've taken the if head dot next equals to null, or head equals to null return node current while current not equals to null, and current dot next not equals to null, current dot next current dot next. This is funny. That's just because I will explain you why. They have put the dot next after null, and over here also the same. That's very funny. Anyways, make sure you guys like, share, and subscribe to the channel. And I hope the code will be working as well. Yeah, it has passed all the test cases. So we have completed around 250 days. So we are 100 days to complete 1 year on GFG, which is around 3 months time period. Okay, for our longest POTD streak. Thank you so much for watching me, and make sure you guys like, share, and subscribe to the channel.